Ted, we're starting to get a lot of models in here. It's time to hire a model middle manager. Welcome to this video on Azure Machine Learning. My name is Kevin Fiesel. I'm the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. In the prior video, we got ramped up on code-first Azure Machine Learning, using a notebook to perform some exploratory data analysis and get us ready to train a model to figure out if people were going to pay their parking tickets in Chicago. In this video, we're going to take what I consider to be a useful sidestep and talk about a product called MLflow. MLflow is an open source product designed to manage the machine learning development lifecycle. In other words, MLflow allows data scientists to train models, register those models, deploy the models to a web server, and manage model updates. The main intent here is to make models available for operational use as quickly as possible and make the experience as smooth as possible. You'll see people make the most use of MLflow in Databricks, as this is where the project originated. But even so, its utility goes well beyond that service, and Azure Machine Learning has some interesting integrations with and parallels to MLflow. So for the purposes of letting you see what the broader world works with before diving into Azure ML specifically, I'll talk a little bit about MLflow itself. Then we'll get into what Azure ML users get if they don't want to stand up and manage their own MLflow servers. Now, MLflow itself is really a suite made up of 4 tools: MLflow Tracking, MLflow Projects, MLflow Models, and the MLflow Model Registry. Let's talk about each in turn. First up is MLflow Tracking. This provides data scientists the notions of runs and experiments. For each run in an experiment, a data scientist may log parameters, track the versions of libraries used, collect and store evaluation metrics, and retain generated output files, including images, when training machine learning models. Basically, MLflow tracking gives us the ability to review and audit prior executions of a model training process. Next on our list is MLflow Projects, a way of packaging up code in a manner which allows for consistent deployment and the ability to reproduce results. MLflow has its own project system, which supports a variety of environments for projects, such as Conda, Docker, and direct installation. Think of MLflow projects as a consistent way of pushing a trained model onto any given machine. The third tool in the suite is MLflow Models. MLflow offers up a standardized format for packaging models prior to distribution. This standardized format takes an input format, such as from scikit-learn, PyTorch, TensorFlow, Onyx, or a variety of others. It then serializes the outputs of that model in a way that we can access them again later, regardless of whichever specific package you use to create the model in the first place. This means that my deployment pipeline can be consistent, and I don't need to know that, say, scikit-learn stores models in pickle format and TensorFlow needs H5 weights. MLflow does all of that processing work for me, and I just need to deploy the saved assets. Finally, we have the MLflow Model Registry. The Model Registry allows data scientists to, register models. Once we've registered a model, operations staff can deploy select models from the registry, either serving them through a REST API or opening up an endpoint for batch inference. Basically, the model registry is our way of saying that this model is ready for a broader audience to use. Now that we have some idea of what MLflow entails, how does this relate to Azure ML? Well, if you already use MLflow for model tracking, you can choose to use it to store Azure ML models as well. You can point to your MLflow server and let it do the job without needing to learn anything new. For most of us, however, that won't be the case. We won't have production-ready MLflow servers hanging around. For that reason, Azure ML has its own model management capabilities, and these capabilities are intentionally designed to be pretty similar to what MLflow has on tap. let's switch over to a demo and we'll see what the Azure ML analogs are for each MLflow tool. Here we are in the Azure Machine Learning Studio, a site which is somewhat more familiar to you by this point if you've gone through the series in order. For this short demo, let's see what the Azure ML equivalents are to various MLflow services. First up is MLflow tracking, which covers experiments and runs. In the Azure ML nomenclature, we have jobs. Selecting this option from the Assets menu brings up a new grid. At the top level, we have experiments, similar to MLflow tracking. An experiment is really just a way of logically grouping together different runs so we can more easily find what we're looking for. We control the creation of any experiments, so there's no hard requirement on when you choose which experiment. As you can see, I've got a few experiments relating to Chicago parking tickets. You can also see that I'm not the best at naming consistency, but moving on. Within an experiment, we have jobs. I'll select the Chicago Parking Tickets Designer experiment, and we can see several job runs associated with the experiment. Here's where we track what actually happened, and assuming we've got the data available, we can compare different job runs against various metrics, such as accuracy or root mean squared error, and see how our models are performing across runs. As part of job tracking, we want to collect as much information as we reasonably can. If I drill into one of these models, like the one at the bottom of the list here, I can see the job graph that we created in the Azure ML Studio Designer. Then, if I select Job Overview, I can get some basic results, including when I ran the job, how long it took, and which compute it ran against. I can also navigate into a series of other tabs, providing me information on the job itself. For example, in the Outputs and Logs tab, I can see the execution logs for my pipeline job. If I navigate to Child Jobs, I can see that each of these boxes in the graph is actually a child job, and I could navigate into these. For example, let's select Train Model. From here, I can choose the Code tab and see the code for that job. This code won't unravel too many interesting secrets behind how Azure ML works, and it's not an example of how we'll need to write code, but there may be a few interesting tidbits in here regardless. And once we start writing and deploying our own code, this tab definitely gets interesting. Now let's talk about MLflow projects. If you happen to have an MLflow server running in your environment and use it to package up code, you can execute that code on Azure ML Compute, so there is compatibility in that regard. If you're not using MLflow and are instead using Azure ML directly for model management, there isn't an exact analog here for MLflow projects. The closest we have is the idea of pipelines, which we can find in the Assets tab. Pipelines are our way of putting together a recipe for action. Do this, then do that, then do this other thing, and voila, trained model. Although these are repeatable processes, it's not quite the same as what we get with MLflow projects, but with Azure ML supporting deployment to self-managed Kubernetes clusters, it's actually a lot closer to the ideal of MLflow projects than it was, say, 18 months ago. But that's enough talk about pipelines for this video. Trust me, we will talk all about them in the next video. But for now, let's quickly discuss models and the model registry. If I switch over to the models page, I can see a list of registered models. This is the Azure ML model registry, and its behavior is very similar to what we get with MLflow's model registry. We can see various models, the experiments they tie to, and even versions. As you can see, there are multiple versions with the name Azure ML Studio Chicago Parking Tick, and if I trained each version at a different time, we can see the results. The idea behind this is that we might want to have multiple versions of a model available. For example, I may want to have versions running side by side for a certain amount of time to make sure that new predictions are actually better than the old model's predictions. By registering these under the same name, but tagging them, we can make it clear that these are competitor models and not totally separate things. Let's select the Chicago Parking Tickets Code First model here. This is a little bit of a spoiler, as we're actually going to create this in the next video. But inside here, we have information about the model, such as how well it performed. The Artifacts tab shows me the trained model itself, which is in pickle format and includes information on the Python environment, including a conda YAML file and a requirements file. This is like the MLflow models tool in that this folder contains everything we need to deserialize our trained model and generate predictions with it. Then, if I navigate to the Endpoints tab, I can see any deployments currently using this model. It says there are none, but this view actually deals with real-time inference and not batch inference, which I suppose is another spoiler. Nonetheless, if I return to the Details tab, I can select Deploy and create either a real-time or batch endpoint based on this model. This means that the operations team doing the deployment doesn't need to know any of the details around how the model came to be and can deploy it regardless of its exact contents. Or they could use APIs and integrate it with their existing DevOps processes, assuming they have existing DevOps processes. Baby steps, people. And that's the kinda complicated relationship between Azure ML and MLflow. We did touch on this in an earlier video, but now that we have some simple model development work under our belts, I wanted to come back to it and show you that there is a method to the madness. In the next video, we are going to write some code to train and register a model, and then we'll deploy it to Azure ML using the Python SDK. We'll have links and show notes in the description below. Until we see each other in the next video, take care.